Hello, students. Here we are. We made it to the end, right? We're at the last week. So this is our last lecture that we will have, and we're going to be looking at the rest of the planets this week. Now, next week we're going to be getting together in Zoom, a Zoom class, so I want to take a look at your rockets. So I'm hoping you have your rockets finished and you can show them to me. I'll go through the last little bits of the instructions on what we're supposed to do to get those finished up. Okay? All right, so here we are. We're looking at the outer planets now. They're very exciting, very different from the terrestrial planets that we looked at last week. So these are known as the gas giants. So as you recall, we have our sun and the terrestrial planets inside there to Mars, and after Mars is the asteroid belt. And remember when we talked about the asteroid belt, we considered the idea that the reason that the asteroid belt is even there was because of the strong gravitational pull of Jupiter, that it didn't allow a planet to form, or it caused a planet to break up, or we're not exactly sure. But what we do also know is that as we look at Jupiter has multitudes of moons, lots and lots of moons satelliting around it, so just orbiting around it. And because of that, it kind of lends us to believe that perhaps some of those moons had come from that asteroid belt. So that's a possibility. All right, we are going to be looking now at our planet profiles. So now you're on page 180. So you're turning the page from last week, and you're going to have a chart with the little statistics for each of these planets. All right, so when you go look at those, you're going to write down a few things that I'll show you, okay, that you're going to make some records, if you will, about these planets, these gas giants. All right, so let's get started with Jupiter. Jupiter is the largest planet in our solar system. Okay, all the other planets in our solar system could actually fit inside of it. It's huge. It's quite large. One day lasts 10 hours, so it's a pretty quick day, and 1 year lasts 12 of our years. Okay, so it takes 12 years to go around the sun. The average temperature, it says here, is negative 244. Huh. I'm starting to wonder if maybe that might be a typo. Check your book on that. Do we see that anywhere else? I think we're fixing to watch a video that tells us the temperature is very hot, so maybe that negative is wrong. All right, it's spinning so quickly, 10 hours, right, to spin around at one time for one day, that those gases and things are just swirling around in it. So those swirls, those beautiful swirls that we see on Jupiter, are really gases. And they're going very quickly, and they're going even the fastest around the middle, around the equator of it. All right, so it has lots and lots, like I said, moons. I can't even tell you how many moons it has because they're always finding new ones. So it's upward to 60 different moons on there. So we know that it's probably gas, and now it says here maybe some liquid. This we're not really sure. You can see it says there's a metal core. We have zero idea if that's true. There are some hints, of course, when we look at magnetism and poles and things like that. So we have some hints there, but it's really kind of silly. So it's very huge, so therefore the gravitational pull is going to be quite different. So on Earth, if you weigh 200 pounds, you would weigh 480 pounds on Jupiter. All right, so we're going to be looking at this atmosphere and things like this. Let's take a look at this video and see the interesting thing. Listen closely for that temperature.
The best way to explore a new world is to land on it. That's why humans have sent spacecraft to the moon, Venus, Mars, Saturn's moon Titan, and more. But there are a few places in the solar system we will never understand as well as we'd like. One of them is Jupiter. Jupiter is made of mostly hydrogen and helium gas, so trying to land on it would be like trying to land on a cloud here on Earth. There's no outer crust to break your fall on Jupiter, just an endless stretch of atmosphere. The big question then is, could you fall through one end of Jupiter and out the other? It turns out, you wouldn't even make it halfway. First things first, Jupiter's atmosphere has no oxygen, so make sure you bring plenty with you to breathe. The next problem is the scorching temperatures, so pack an air conditioner. Now, you're ready for a journey of epic proportions. For scale, here's how many Earths you could stack from Jupiter's center. As you enter the top of the atmosphere, you're traveling at 110,000 miles per hour under the pull of Jupiter's gravity. But brace yourself. You'll quickly hit the denser atmosphere below, which will hit you like a wall. It won't be enough to stop you though. After about 3 minutes, you'll reach the cloud tops, 155 miles down. Here you'll experience the full brunt of Jupiter's rotation. Jupiter is actually the fastest rotating planet in our solar system. One day lasts about 9.5 Earth hours. This creates powerful winds that can whip around the planet at more than 300 miles per hour. About 75 miles below the clouds, you reach the limit of human exploration. Galileo probe made it this far when it dove into Jupiter's atmosphere in 1995. It only lasted 58 minutes before losing contact and was eventually destroyed by the crushing pressure. Down here, the pressure is nearly 100 times what it is on Earth's surface. And you won't be able to see anything, so you'll have to rely on instruments to explore your surroundings. By 430 miles down, the pressure is 1,150 times higher. You might be able to survive down here if you were in a spacecraft built like the Trieste submarine, the deepest diving submarine on Earth. Any deeper, and the pressure and the temperature will be too great for the spacecraft to endure. However, let's say that you could find a way to descend even further. You will uncover some of Jupiter's grandest mysteries. But sadly, you'll have no way to tell anyone. Jupiter's deep atmosphere absorbs radio waves, so you'll be shut off from the outside world, unable to communicate. Once you've reached 2,500 miles down, the temperature is 6,100 degrees Fahrenheit. That's hot enough to melt tungsten, the metal with the highest melting point in the universe. At this point, you will have been falling for at least 12 hours, and you won't even be halfway through. At 13,000 miles down, you'll reach Jupiter's innermost layer. Here the pressure is 2 million times stronger than that of Earth's surface, and the temperature is hotter than the surface of the sun. These conditions are so extreme that they change the chemistry of hydrogen around you. Hydrogen molecules are forced so close together that their electrons break loose, forming an unusual substance called metallic hydrogen. Metallic hydrogen is highly reflective, so if you tried using lights to see down there, it would be impossible. And it's as dense as a rock. So as you travel deeper, the buoyancy force from the metallic hydrogen counteracts gravity's downward pull. Eventually, that buoyancy will shoot you back up until gravity pulls you right back down, sort of like a yo-yo. And when those two forces equal, you'll be left free-floating in mid-Jupiter, unable to move up or down, and no way of escape. Suffice it to say, trying to land on Jupiter is a bad idea. We may never see what's beneath those majestic clouds, but we can still study and admire this mysterious planet from afar.
All right, I'm not sure how they knew all of that stuff about about the metallic hydrogen and things like that, especially if we can't get any radio waves out of there. I don't know how we've had any data from that, but it's interesting to ponder and to think about, and we can probably rest assured we're not going to be going to Jupiter, right? Yeah. Okay, so let's look at those relative sizes. So the sun, of course, is the largest thing in our solar system. You can see how huge it is. And then we see Jupiter here. And then our Earth is this little tiny dot right there. Yeah, so its diameter is 11.2 times the diameter of Earth. So it's really, really big. It has that big, you may have noticed in a lot of pictures of it, there's that giant red spot there. It turns out that's a massive storm, sort of like a hurricane. And it is raging all the time. As far as we have seen it, it is raging all the time. So it's always got that storm there. But it does change size. Sometimes the storm gets bigger, sometimes it shrinks and gets smaller. The last I read about this was that it was trending toward getting smaller right now, but I'm not sure today if that is the case. It turns out that it does have some faint rings circling it, that we found that out when we saw some x-ray pictures of it. And then we know it has lots and lots of moon, up to 60, 70, I don't know, tons of moons out there. And but there are 4 that are quite large that we know about that are kind of like a terrestrial planet, in fact. There they are. Okay, so we're going to look at the different ones here, and they're all, of course, orbiting around there. This one's called Io, and I think that maybe it's that one right there. Io is interesting because it's totally and completely volcanic. So now that red you see on there is like flowing lava. All right, so it just looks like a big pizza, right, where the cheese all melted on it. So it's just constant lava fields and things like that. Okay, let's just go back a second right here, because let's try to figure out which one these are. So one of those is named Europa. It might be that one. And then we have Ganymede, which I'm not sure if it's that one or that one. We have Io and Callisto. So one of these, I think maybe this is Callisto, making that one Ganymede. And then, of course, Io right there. Okay, so those are the big ones. These are ones that people have wondered if maybe we could, make that into a new Earth. We could go live there. We're not really sure. So we have sent some probes out to Jupiter to get a look from the outside. As the video mentioned, the one we tried to slip down into the atmosphere didn't last very long. But you see here, I think it's sending a signal, picking it up, and we're getting all those really great. We have really good pictures from Jupiter. So on page 1, I think it was 170, right? Not 175. Is that page number right? We know that it is the largest planet. Its day length is 10 hours. Its year length is 12 years. It's the 5th planet of the sun. It's the largest. And the great red spot is a storm. And the surface is made up of liquefied gases. Now that, I guess that's what that video was trying to tell us, that it was liquefied gases. So it's gases that have been pushed into a state of liquefaction, apparently. Okay, I guess that's all we have for Jupiter right there. Saturn comes next. Many people find Saturn to be their favorite planet only because it's just so beautiful, right? It's lovely looking. Those rings are just mesmerizing. So its rings are quite bright. In fact, it was Galileo who saw the rings first, but he did not know what they were. So he looked up and saw the planet. It looked like a ball with a line going straight through it. So he never did quite figure that out. If it had been on its side, he may have seen that they were actual rings going around there. So what are the rings made of? We'll get to some pictures of those, and there's large chunks in ice and rocks going around it. So they're orbiting. And some people think that possibly those are broken up moons and things like that. And there are moons embedded in there, and Saturn has many moons as well. Its day is 10 hours. Its year is 29 years. So it takes 29 years to make one trip around the sun. And we have an average temperature here. Once again, it gives us a negative 290. So let's check that and see if that's the case. I just am having trouble with my temperatures today. It has over 30 moons. So it can be seen with your eye, although I don't know if I can see it. I don't know if I'm, trained well enough to pick it out of the sky. If someone points at it and says that star right there is Saturn, okay, got it. Is this telling us right here that Galileo, yeah, he was the first one to see it, and like I said, he couldn't quite figure out what that line was going through there. He just noticed there was something happening. It's got a very thick atmosphere. Remember, it's a gas giant. It may have a core of some sort that's solid. We're not sure. And of course, the ring system is amazing. It says here, that's interesting, that it's 1.1 the gravity of the Earth, which is strange because it's so big, right? But its mass is not great. In fact, they say that if you could a bathtub big enough, it would float. It's very not dense, all right? So you could float the whole thing in a tub of water, is what they say. Once again, not sure how they know that. We can see right here one of the moons is called Titan. That's like one of the famous moons that it has, and then a couple of others there. Let's watch a little video.
With its gold color and stunning rings, Saturn is quite a planetary gem. Saturn is the second largest of the 8 planets, and it is about 10 times as wide as Earth. Despite its size, Saturn is actually the lightest planet. It is predominantly made of the gases hydrogen and helium, and because of its particular gaseous composition, Saturn is the only planet in the solar system that's less dense than water. If the planet were placed on an enormous ocean, it would be able to float. Saturn's gaseous makeup also means that it has no true surface. At its center, the planet has a dense core of water, ice, and rocky material, but it has no actual landmass. Instead, it's mostly made of gases, liquids, and yellow ammonia crystals that swirl around the planet, creating golden clouds and storms. The largest storm on Saturn is at its North Pole. It's over twice the size of Earth and shaped in a near-perfect hexagon. Each of the 6 sides is believed to be the result of jet streams, which all encircle a massive hurricane. Because of Saturn's inhospitable environment, the planet cannot support life, but some of its moons might. Saturn has more than 50 confirmed moons, and each varies in size and terrain. Enceladus, one of Saturn's smallest moons, is covered in ice and only about as wide as the state of Pennsylvania. Titan, Saturn's largest moon, is nearly as wide as Canada. Titan is also the only moon in the solar system with clouds and a dense atmosphere. Both Titan and Enceladus have underground oceans that would make them potentially capable of sustaining life. Saturn's moons may also play a role in shaping the planet's signature feature, its rings. Saturn's ring system is the largest and most complex in the entire solar system. The rings are made of icy and rocky remnants from comets, asteroids, and moons. The particles range in size from being as small as dust to as big as mountains. The ring system is divided into 7 groups of rings. Altogether, they are as wide as 4.5 Earths, but only about 2/3 of a mile thick. How the rings are able to stay on track and intact has to do with Saturn's smallest moons. Called shepherding moons, these tiny satellites orbit between the rings, and they seem to use their gravity to shape the ring material into circular paths. Saturn has fascinated scientists and amateur astronomers alike for thousands of years. The ancient Greeks and Romans, who named the planet after their god of agriculture, believed it was a star. It wasn't until the 17th century, after the telescope was invented, that scientists like Galileo Galilei, Christian Huygens, and Giovanni Cassini could take a much closer look. Only then was Saturn's planetary status discovered, and ultimately its many moons and brilliant rings. Because of its planet-like moons, lightweight composition, and dazzling ring system, Saturn continues to mesmerize us to this day.
Okay, pretty cool. Yeah, I like Saturn. I think it's one of the things I'd like to do is when God lets us to go, maybe he'll let us go visit these planets, right? I'd love to go visit Saturn. So there's a picture. That's an actual photo that we've taken, and you can see there's a moon right down here. The shadow of the planet is on the rings right there. So notice how those rings have different little stripes. It turns out that they have these regions where there's not very much activity. Now, see that right there? Those things are actual moons. Those must be some of those shepherding moons right there. And there's a bunch of them, right? So you can see them with a telescope. So if you have a telescope and you can look up, if it's visible in the sky, try finding it. So they're wide, about 600,000 miles wide. That's what the video said, but only a half a mile thick. And it has those little breaks in there, and each one of these has names. Do I have that on here? Yes, so our rings, okay, so the Encke division and the Cassini division, those little blanks in there. So F, A, B, C. So however they've chosen to label those, it's just something that astronomers have done over the years. And so Cassini division was named after Mr. Cassini, who was one of the guys who was one of those early astronomers who was looking at it. Okay, so it's satellites or moons. We could start to see some of those moons right here. Let's see. Do we recognize any of these names? Where was the big one? So look how far some of them go out. So Rhea and Dione and so this one they talked about in the video, right? Enceladus. Yeah, so I don't know where Titan went off to. But here's our divisions in the ring. So you can see also, I don't know if they're mentioning the rings right here, but there are some moons they're mentioning as well. Yeah, here's some moons right here. Okay. So quite a few, right, coming around there. And I guess you might even consider all this out here even some sort of ring. Oh, look, Titan's that way. Okay, so it's even farther out. All right, so on our page, we're looking here. We say that Saturn is the ringed planet. The day is 11 hours long. The year is 30 years. So it takes 30 years to go around the sun. It's the 6th planet from the sun. It's the 2nd largest planet of all after Jupiter. It has highly visible rings, and it says here it has the most moons. That may not be accurate, but it could be. All right, so because Jupiter has so many moons as well. All right. Moving on to Uranus. So it's a large, cold planet. In fact, I believe some people called this not a gas giant, but something else, a cold giant or something like that. So it has clouds of methane gas. Now you might wonder, well, how do we know that? Well, it turns out just the same way we can put our spectroscope on the sun and tell that it's hydrogen and helium, we can put a spectroscope on these planets and we can get a reading about the kind of gases. So when gases are, they put off a certain spectrum when you have light on them. And so we can see that's methane gas, which is CH4, so it's a carbon type of gas. Typically, that's something that burns down here. It's tilted so far in its axis that it actually rotates up and down instead of side to side. So it's tilted up and rotates sideways. Does that make sense? All right, so one day is 18 hours. It takes 84 years to go around the sun, and the average temperature is negative 350 degrees. It has 11 faint rings that you can see in some photos, but not with just looking at it from the telescope. Let's see. It has a thick cloud cover. We can't see into it. There's possibly, it says here, a rocky core. Not really sure. We think there's hydrogen, helium, methane that are surrounding it right there. All right, interesting here. Once again, the gravity is only 0.9. Oops. Sorry about that. The winds are about 450 miles per hour. And there's our rocky core there. Okay, so this is that picture we saw with those rings. So see what I'm talking about? Instead of being this way, the rings are going this way. So it's tilted all the way over on its side. And sometimes when we look at it, it looks quite plain like that. Just a very light, baby blue kind of a color right there. All right, so it's the planet that rotates sideways. It's a 17-hour day and an 84-year year. The 7th planet from the sun, it rotates on its side. The atmosphere of methane gas and a blue-green color. Long periods of dark and light. Which brings me back to the idea of going to the moons of Jupiter or Saturn to have a new Earth or whatever. They're really far away from the sun. I don't know how they're supposed to get warm enough. I guess if they have an atmosphere, but still, how do plants grow without sun, being closer? No, yeah, I think it's a little bit of a dream that way. All right, moving on to Neptune. It's cold and distant, very far away. It's also a methane atmosphere and some swirling storms. It's very, very blue. It's actually very pretty, and it's blue. It's 19 hours for one day and 165 years to go around the sun, with an average temperature of negative 373. It says it's a tilted axis and therefore has seasons like the Earth, but those seasons last 40 years. It has faint rings around it and 8 moons. The unusual orbit causes it to be further away than Pluto sometimes. I'll show you that little track of that here in just a second, a little orbital track. Okay, so let's see what it tells us over here. Let's see. If we could do a 10-foot dunk here on Earth, we can only do 8.5 because we're being pulled down by all the gravity there. Let's see. They found out that there must have been a planet Neptune out there because of studying other planets. They saw something happen, and what they saw was it's called a perturbation, where it causes a gravitational wobble. And so when they're looking at Uranus and they saw this gravitational wobble, they said, well, there must be some other planet pulling on it over there. So they guessed that there was another planet out there. And it turns out they were right. When we had better telescopes, we found it finally. And then we were able to see. And now, of course, we've got some pictures of it. It says here it's got the fastest winds in the solar system at 1,300 miles per hour. Okay. So this is the possibilities of what it might be made of on the inside right here. It has a moon called Triton. It's the major moon, and it says it orbits backwards. Interestingly, instead of going around the normal way, it goes around retrograde. That's kind of cool. And also, this is a famous spot here. It's like a blue spot, the Great Dark Spot, they call it. So there it is. Guess what it is? Just like with Jupiter, it's a big storm that's raging there in the gases along the surface of that planet. Here's some composite photos of that moon, Triton. And you can see it looks like it's got lots of craters in it and some maybe some traces here. Some people wonder if maybe that's ice and the ice with the cracks in it and things like this. You know, it could be frozen something that's not necessarily frozen water because it's way out there. So I would imagine it's pretty cold. So it's the blue planet. It has a 16-hour day and 165 years to get around the sun. It's the 8th planet from the sun. It has violent weather. There's a great dark spot, and the clouds are more than likely methane gas. Remember, you can pause that if you need to fill in your chart. It takes a little longer for you to do that. All right, now Pluto, poor Pluto. It's no longer considered our planet, right? It's considered a dwarf planet, sadly, okay? It was also very limited knowledge on Pluto because it's so far away. It does orbit around the sun. So why in the world would they have taken it out from being a planet? It's now considered a dwarf planet. Well, there are different criteria. There are 3 criteria to be considered a planet. One of them is it has to orbit the sun, and the moon does that. I mean, excuse me, Pluto does that, and so therefore that it fills that criteria. It orbits the sun. Number 2, it has to be relatively round. Okay, so round would be its formation in the gravitational pull that would give it a round shape. So it's round. And then the 3rd criteria is it has to have enough gravity to clear its neighborhood. And what that means is that anything around it, it may take into orbit, like a moon, which it does have a moon named Charon right here, right, or Charon. That goes around it, but it turns out that it doesn't have enough gravity to clear its neighborhood. Okay, so that means it's getting crashed into by things and this kind of thing. So that's why it's been called a dwarf planet. There's actually a dwarf planet a little larger than it beyond it out in the Kuiper Belt, and now Pluto is actually in the Kuiper Belt as well. It takes 247 years to go around, and the average temperature is -393. By the way, it's not a gas planet. It's a solid planet. It's a terrestrial planet, the best we can tell. All right, we think it's like this. We think it's icy. It's possible frozen water. So we just think we think it is terrestrial. It does have a solid surface. All right, so here's what happens is Pluto is usually here, okay? So and it's so far away, but every now and then Pluto actually comes inside the orbit of Neptune. So Neptune becomes the farthest planet out sometime. So that was in 1989, right? I'm not sure when it's supposed to come back to do that. But just very recently, we were able to actually get actual photos of Pluto. We sent a probe out there, but it took so long to get to it that it took many years to actually get photos. And I'm not sure if this video shows us the photos or not. Let's try. Let's see.
At the edge of the solar system, Pluto pushes the boundaries of our understanding of the universe. Nestled within the far-flung Kuiper Belt, the dwarf planet is believed to be one of countless celestial objects left over from the formation of the solar system. While it is one of the Kuiper Belt's largest bodies, Pluto is only half as wide as the contiguous United States and about 2/3 the size of Earth's moon, making it easily dwarfed by the solar system's 8 true planets. This tiny world takes 248 Earth years to orbit the Sun, and it does so from an average distance of over 3.6 billion miles, or 40 times the space between Earth and the Sun. Such a distance from the solar system's main source of heat causes extreme temperatures on the dwarf planet's surface, between -375 and -400 degrees Fahrenheit. The frigid temperatures play a crucial role in shaping the geological composition of Pluto. Its core, likely made of rock and metals, is encapsulated by a mantle made of ice. The dwarf planet's crust is made of rock material and other types of ice, such as frozen carbon monoxide, methane, and nitrogen. These frozen gases cover Pluto's approximately 6.4 million square miles of surface area, which is barely the size of Russia. The icy terrain is much like Earth's, with polar ice caps, valleys, plains, and craters. It even has glaciers made of frozen nitrogen, and frozen water on the surface makes giant floating mountains. Such varied terrain is influenced by the presence of weather patterns, or an atmosphere. Pluto's atmosphere is thin and reaches a high altitude due to the dwarf planet's low gravity, which is only about 6% as strong as Earth's. The atmosphere is comprised of nitrogen and methane gases, plus red hydrocarbon particles that scatter sunlight to give Pluto blue skies. Parts of the atmosphere may even freeze and fall like snow. Floating high above the dwarf planet's atmosphere are 5 moons. The largest, Charon, is about half the size of Pluto. The 4 other moons, Nix, Hydra, Kerberos, and Styx, are much smaller. While the 8 true planets were discovered by the mid-1800s, Pluto was not spotted until 1930. Pluto, named after the Roman god of the underworld, was considered the 9th planet. But in 2006, Pluto lost this status. At the time, worlds similar to Pluto were being discovered deeper in the Kuiper Belt. This initiated close scrutiny of Pluto and the definition of a planet. The International Astronomical Union evaluated Pluto based on the characteristics necessary to be a true planet. It must orbit the Sun, is not a moon, and has enough mass and gravitational pull to assume a round shape. However, it was the 4th characteristic that compromised Pluto's status: its inability to clear its orbit of debris. So, Pluto was reclassified and arguably demoted from being a true planet to a dwarf planet. Pluto's story represents our evolving understanding of the universe. There is always more to discover, and we are continuously reaching toward it.
Okay, there you go. I have no problem calling it one of our planets. And furthermore, they keep kind of changing their mind. I think they were starting to change their mind back to calling it a planet. But I think officially right now it is considered a dwarf planet. By the way, the photos they showed of it in there were the new ones, okay? So those were brand new, probably 2 years ago or so, that those photos were obtained through our probe that went out that far. Nice to see that those were the actual photos of that surface of it. So it's pretty cool looking. We decided it used to be just a shiny little tiny star in the sky. All right, so it's the smallest planet, although okay, I believe that the time this was originally written, my PowerPoint was originally written, it was actually still a planet. Okay, so now instead of it being the smallest planet, it's going to be a dwarf planet. It's probably not even on your pages, right? Probably not. 6.4 days for 1 day and 248 years to go around the sun. So it's the 9th planet, although now it's a dwarf planet. Smallest and coldest. It has that weird elongated orbit, and it's considered a double planet because of its orbiting with its moon Charon or Charon. It's almost like it's on a stick and it's going around. They're orbiting each other, kind of, so almost like a dual system right there. All right, so this is a review. You're going to name the planets in order. You should know those by now. You don't have to include Pluto in that. All right. Which reminds me about our quiz that we're supposed to be having. I'm going to see if maybe I can get that onto the Google Classroom for a quick little multiple choice quiz for you. We'll see. I'm not sure how that's going to work, but we'll know by next week, before next week. All right, we're going to do our little lab now. Let's see what I have to say. Hey, y'all. Okay, so we're going to be finishing up our rocket this week. And there's this part of your rocket, right? So the nose cone of the rocket, and it looks like this. Now, it's got this part right here that is actually kind of hard. It needs to be popped out. It's kind of hard to get out, so I'm going to ask you to get your folks to help you with this. They probably just take a knife and then stick it right in. That's what I did, and I got it out. It looks like that. See? So we have a hole right there now because our parachute's going to go in there. All right? So typically when I get these for my students, I don't use a parachute. I use a streamer. But this particular item came up and it was on sale, and so I got this one for us. The problem with the parachute is that it may take the rocket farther away than a streamer just comes straight down, and the streamer's there so we can see it. But since we are going to maybe be launching these elsewhere anyway, then maybe it'd be okay to have our parachute. Parachutes are cool, right? All right, so you're going to put this in here now make sure you have all 3 of the strings. Okay, so there's 3 different strings holding on to different parts. So like here I've got 2 of them, and then I have my 3rd one. All right, so make sure they're not tangled. This can get a little bit, in the old days we used to have to actually tie these strings on ourselves, which was always a hassle. So I'm glad that these were already tied to your parachute. Okay, so now it looks like this one's going to go in the middle and the side. Okay, so I have them in order here. And I'm going to take these and make it kind of small like that. And push it through that hole we just made. Like that. All right, then I have all 3 of them again. Make sure I've got all 3 of them. And then I'm going to take my parachute and put it through here. All right, then you can pull on it. And now you can see how my parachute is attached to my nose cone right there. Okay? All right, so we're definitely doing that part today. So what we're going to do, y'all, is once we get our whole rocket, it's going to be put in there with our little string on it and everything, the rest of it, which we'll get to in just a minute. And then hopefully have our rockets completely finished. Okay, all right, I just want to do this part on camera for you. Okay, gang, see you soon. Okay, so also connected to the nose cone right there is going to be that little elastic piece of string right there. And you're connected with this deal right here. All right, so this is called the shock cord mount. And I know a couple of you had a little confusion about this. It's actually on the front page of your instructions, and it looks like that, this little 1, 2, 3 right here, okay? You're going to cut that out. So get some scissors and cut that little part out right there, and then we're going to look at these instructions right here. So what you're going to do, so you cut it out. That's what it just came from the front page. And then you're going to fold it and see where it tells you to glue it right there, and then you fold this piece over, and then you glue it again and fold this piece over. So you're securely gluing in that elastic band thing right there, okay? So you're gluing that into this little piece of paper. All right, then you hold it till it's set, okay? And then you're going to take it with some glue and put it on the inside of the top of the rocket. Notice it says not right on the edge, because then the nose cone's not going to fit in there. You have to push it back a little bit so it's deep enough that the nose cone doesn't get pushed out. So just put it back there far enough like that. And then, of course, let that glue dry. So this is the part we did right here. We knocked that out, put the parachute in there, and now notice our shock cord is also tied on there. So it was glued in that end there, and then it's tied on the end right there, okay? So then this is a little hint if your nose cone doesn't fit. Hopefully it'll fit, and mine fit into the 2 that I tried it on right there. Okay, so then we're going to be able to, you're going to fold now that parachute up, and you're going to stick it down into the tube and put everything down so we won't be able to see the parachute, right? And therefore what's going to happen is now what we should have a pretty much complete rocket as far as the parts go, as far as the steps we've taken along the way. If you've been following, that's fine. If you haven't and you want to get started, just follow these step-by-step instructions, and you can go back and look at the end of the other, except for that one I forgot, right, to do the rocket part on it. And so then you can do your decoration of it. So there's those cool stickers that are on there you can put on. You can use markers. You can do whatever you like. Just don't glue anything onto it that might make it too heavy. Okay, so just use like stickers are about as heavy as you want to go on that. But you can use, markers or paints or anything like that. Okay, so if we'd been together today, we would have had some other things we were doing for lab. I just threw this in there because I thought that was kind of cool. That might be a fun project to do if you had some really nice beads, and you could see how you could have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto in there. That might be kind of fun. But I have some inflatable planets, and they, they're not to scale, which kind of bothers me a little bit. And the rings that are around Saturn are kind of floppy. And then there was this little art kit that I have called a marbling kit, and you can put these paints in like floating on top of water, and then you put a piece of paper down and bring it up, and you end up with this really cool swirling like picture like the surface of Jupiter. Our Jupiter model would have been just a giant one of those punch balloons, we would have blown one of those up and draw a red circle on it as the great red spot, and then some swirls around it, some lines around it, you know, that kind of thing. It would have really depended on how much time we had at the end of class to do any of these. We could have done some as demonstrations, and then of course we wanted to finish up that rocket. Okay, so here's what we're going to do next week. We're going to have a Zoom class, and you're just going to show your rockets to me. I realize we can't launch them, sadly, but like I said, we're going to, you know, you're going to hold on to them and keep them somewhere safe so that sometime we'll figure out a time. You know, right now we're still not in a point where we can get a large group of people together. And I've got the rockets here, the engines here. You have the rockets, I have the engines. And I have the launch pad and the launch rod and all that kind of stuff. So I really, really hope, and I really intend at some point to try to get those launched. But keep them sitting on your shelf, you know. You can put a name on it if you want to. You can name it, something like that. All right, I'm super glad that we will have a chance to get together. I'll get to see your faces again before the end of the school year. Normally what we would have done on the last day, of course, we'd have the launch on one day and then the last day a Jeopardy game kind of a thing. So that's not going to work out for us. We missed that week after spring break and everything like that. But we will be able to, at least I'll be able to see you and to see your rockets. And so I'll be sending that information out, and I'll let you know about that quiz, how we'll handle that. Okay, I'm still figuring out my quizzes for my older students, and so once I get it figured out with them, then I'll see what I can do with y'all. Okay? All right, gang. Well, I'll see you next week. We'll have fun. All right. Bye.